Hello, everyone. Thank you for coming by. This is a SQLite-vec event happening in the Mozilla AI Discord today, December 17th, Tuesday, 2024. Today, I'll be talking about llamafile and SQLite-vec. We've talked about SQLite-vec before, all the cool features you could do with it, storing embeddings inside of SQLite, performing vector search, KNN style queries, all that stuff. That is all low-level operations that you need when you're working with vectors and embeddings. And one application of SQLite-vec is with RAG, or Retrival Augmented Generation, one of the many cool new AI application features that have come out recently. So we're going to be talking about how you can do that with llamafile. So SQLite-vec and llamafile, this will be a quick introduction to both of those things, and we'll go over a quick demo of how you can make it work and a few new features that might be coming to llamafile soon that will make all this a little bit easier. One little hiccup that I had working on this event is earlier last week, I broke my laptop. As you can see here in this very pretty picture, I'll make it full screen so you all can see a little bit better. In this very pretty picture, very similar to, I was working on my laptop. I had a cup of coffee. It wasn't this cup of coffee. It was a peppermint mocha that I had in a cool little Christmas cup. And I dropped the entire thing on my laptop. It was milk. I was hoping I could fix it. I took it to a guy so you could open it up and try to clean out all the insides, but the motherboard is completely fried. So I unfortunately lost my laptop. I did not lose all my work. Most of my work is in Git repositories and synced to GitHub and everything. Although I did lose some notes and all that, but more importantly, I lost a lot of time over the weekend. So this presentation isn't as complete as I would have liked, but I still have a few demos and a few code examples to show. So think of this session as just a complete introduction to RAG using llamafile and SQLite-vec. It is not a comprehensive view of what you can do with RAG and llamafile. I'll do a quick introduction in this event, and then probably next month we'll do a more in-depth view at it with advanced features and all. So just keep that in mind. Number one, don't drink mochas right next to your laptop. And number two, remember that we will do a bigger event later next month. Just want to point that out. Retrieval Augmented Generation. The basic gist behind this is that if you're building an application using LLMs where a user provides a query and you generate a response given to that, one thing to know is that large language models don't know everything, right? These large language models, they weren't trained on the internet or other data sets that these large AI labs have, but they don't know everything, right? They don't, first off, their context cutoff is up to a certain point, right? So you might be working with a model that only has data from April 2023 and before. So for events that happened more recently, say the US presidential elections, it doesn't have context or doesn't know about that inside of the model itself. Now, you could provide context to an LLM. Whenever you ask a question, you can provide context like, oh, here's a news article, so please summarize it. Or here are some recent events that happened in the world. Please use this to determine your answer. But know that large language models have a limited context window, right? You can only feed so many tokens to a large language model before it can't really do much with it. And there's also some performance issues with that. So if you provide too much context, it might get confused or it might answer wrongly, or you provide context that's wrong, that may not work well. So the solution is Retrieval Augmented Generation, all right? So it is a technique where when you want a large language model to answer questions about a private data set or about a data set that isn't in its training data, what you do is you retrieve information based off of a database or a other data source that you have. You retrieve that information and you give it to a generative model to answer questions about that. And the way that we're going to do it here in this event is for the retrieval part, we're going to be using SQLite-vec and full text search. So that way we perform hybrid search based off of a given user's query. So that's where we retrieve information. And to generate an answer to the question that the user has, we're going to be using llamafile. All right. Now, llamafile, if you have not heard of it before, I highly recommend it. There are many different ways to run large language models locally, and I would say llamafile is the best way to do it. You can go to llamafile.ai or just look up llamafile. There's a GitHub repository for it. And it is a project run by Mozilla, created by Justine, they have a channel inside of this Mozilla AI Discord. If you're here right now, check out the llamafile channel, great people in there. What it is, you can run it is a single file executable for running large language models and embeddings models. So you just need this one file, you download it, you make it executable. It has the embeddings model, it has the model weights embedded inside of that file. So that's all you need. You don't need Python, you don't need other dependencies. You run that and you can get a JSON API to make requests to programmatically if you have a Python script or Node.js script. So you make an HTTP request to llamafile to this running server that's running. It will generate completion. It'll complete or answer questions about whatever you have, response back. You could have that in Python or Node.js in a completely separate process. There's also a nice little chat interface using it with an HTML that you can use. There's a command line interface, a REPL. There's many different ways to interact with llamafile. I would say it's the easiest way to go about it. I think the best thing is that it really is a single file, so no dependencies. This file works on all operating systems or all modern operating systems, so macOS, Linux, Windows. I would say it is the easiest way to work with large language models and to also generate embeddings, right? So check it out. We'll go into some code samples in a bit, but check it out if you haven't. Again, this is for the generation part of RAG. And for the retrieval part of this RAG demo, we're going to be using sqlite-vec. We've had many events on this about sqlite-vec and some of the cool features about it. If you check out the Google Doc, I have a link at the very bottom to these other events that we've done, as well as recordings of those. But if you want to learn more about sqlite-vec. But one nice thing about SQLite-vec is that it is also very low dependencies, actually no dependencies. You do need SQLite, of course. It is a SQLite extension that adds vector search capabilities to SQLite. So you do need a SQLite library running, whether that's in Python or Node.js or whatever other programming language that you use. But we will be storing embeddings inside of SQLite using SQLite-vec, performing KNN searches on top of that. And we will also be using SQLite built-in full text search extension that they have. So we had an event about this about 2 months ago. So check it out. It's about hybrid search. Usually vector search alone isn't that great. Hybrid search steers you in the right direction a little bit. So in this demo, we're going to be using hybrid search with SQLite-vec and SQLite full text search FTS5 to perform RAG on the example data set that we're going to have. And if you have any questions during all this, feel free to drop it in the chat and I can answer it at an appropriate time. But now the demo that we're going to build today is going to be an ultra low dependency RAG application using a Python script, using a Jupyter notebook, where we will use llamafile and SQLite-vec to perform RAG to create this SpongeBob episode bot application. All right. So what I kind of want is a little bit of background. A lot of RAG examples that you see, if you read blog posts and see what people post about, a lot of these RAG examples, it's a little bit difficult. When you want to show off what RAG can do, most of the time when people are going to be applying RAG and using it in some application, it's on private data, right? So you can imagine a RAG application that answers questions about like your internal company FAQs, right? So you can imagine a bot where it's like, oh, what is our PTO policy on employees when they're here less than 6 months? Questions like that, right? But that's on a private data source. That's on your internal company documents, your internal human resource documents. Now, the LLM doesn't know about that, which is why you need RAG to perform context with that. But that's also a private data set. No one's going to share that online. No one's going to make that public so that way people can try out RAG, right? So it's difficult to find a good data set to perform RAG on. It has to be one that's private, that LLMs don't know about, and it can't be too broad that LLMs do know about it, right? I've seen a lot of examples where people perform RAG on Wikipedia, for example. So they take Wikipedia articles, they embed them, and they show, oh, you do RAG and you provide this context to an LLM, it'll answer questions about it. But the problem with that is that most LLMs were trained on Wikipedia, right? Wikipedia is in its training data. It could probably answer a lot of those questions without any context needed. So I wanted to find a good data set that's public enough where we can like play with it and scrape data and have something that's accessible to everyone, but not public enough where an LLM is probably trained on it. So my solution to this is SpongeBob. So SpongeBob SquarePants, excellent cartoons I used to watch growing up as a kid. Now, SpongeBob is a very popular TV show, but the episode synopses of what happens in each individual episode is a little bit difficult for some LLMs to understand, right? If you ask OpenAI, those large language models that run on tons of GPUs on server farms elsewhere, those might know about specific SpongeBob episodes, and it might be able to answer questions about it. But these smaller local LLMs probably don't. For example, in this case, we're going to be using Llama 3.2 1B, which is a very small LLM that doesn't have too much, that was trained in a similar way, trained on the entire internet, knows how to answer questions and knows how to respond in like general English, but it may not know about specific SpongeBob episodes. So if you ask it about a specific plot of what happened in a SpongeBob episode, it's not going to know about it. So this is a good example of how you can use RAG on a somewhat private data set. It's not in the training data for an LLM. So it's a good little example to show how RAG works. So what we're going to do is there's a SpongeBob Wikipedia. So we're going to scrape the plot episodes from that website. We're going to get that data, load into SQLite database, do some chunking, talk a little bit about RAG, and then finally build a bot that can answer questions about SpongeBob plot episodes, given the data that we've scraped and given the data and the context that we give to a large language model. And as a side note, if you are a SpongeBob fan, a friend of mine he's a YouTuber. He makes a lot of YouTube videos. He has one specific video about Squidward that is 2 hours long. It is a very deep dive into the character of Squidward and of SpongeBob in general. So if you do like SpongeBob, check out that video. It's great. I've watched it. You can learn a lot about SpongeBob history and all that. But anyway, so what we're going to do is our goal is we want to scrape the SpongeBob episode plot points, store them in SQLite. We're going to do some chunking and embedding on those plot synopses. It's like a couple paragraphs per episode that just talks about what happens. So we're going to chunk those paragraphs, embed them, store them in SQLite. And then we're going to build a little bot that when a user asks a question, we gather context using the private data that we have, provide that context to a large language model, and then hopefully it will answer the questions correctly. And then we can have a little SpongeBob bot a RAG powered SpongeBob bot using llamafile and sqlite-vec. So that is the main goal that we have for this little demo. So I'm going to switch over to a Jupyter notebook that I have. Perfect. Okay. So first off, if you have trouble seeing the screen or anything, if you want me to make the text a little bit bigger, go ahead and let me know. First off, this first notebook, this is a Dino script that just scrapes the SpongeBob Wikipedia page that we were talking about before. I won't go too into the specifics of how it does it, but essentially, if you want to scrape any Wikipedia-based site or media wiki-based site, which this fandom SpongeBob website is, there is a undocumented API that you could use to gather the raw Wikipedia text for that article. And there's this NPM package called WTF Wikipedia that can parse that and provide more information out of it. So in this case, it's not like we're scraping the raw HTML and gathering data for it. It's a slightly nicer JSON API that we can use to get all the episodes of a specific season, get the synopsis for a specific episode. And at the very end, using Dino and SQLite, we have a SQLite database that has, for the first 3 seasons, every episode, the name of the episode, and the synopses for that episode. So again, each synopsis is a few paragraphs that just talks about what happens in the plot. So like SpongeBob does this, Patrick does that. And we just store those raw synopses in SQLite from this Dino script. So we use Dino to scrape that data. We have it. So now we're going to move over to Python to do all the LLM SQLite-vec stuff. This is just to prepare a nice little data set to use. You can imagine that if you want to do RAG yourself using another data set, whether it's another Wikipedia or like your own private data, just try and get your data into a SQLite database just to make things a little bit easier. And in this case, we just did in a separate script just so we can have another reference to it. So if you want to check that out, again, I will drop a link to this in the Google Doc that I shared before. If you're in Discord right now, if you scroll up a little bit, there's a link to a Google Doc. I will include this notebook in there as well after this event. So now that we have a SQLite database full of SpongeBob episode plots, now we're going to work with llamafile. All right. So in this case, we need 2 different models for this RAG application. We need one embeddings model. This embeddings model is going to be much smaller. This is what will generate an embedding for us. So we provide it text. In this case, it's going to be a SpongeBob plot, a SpongeBob episode plot. We provide text, and in response, we get an embedding or a vector of floating point numbers that we could use to store and perform better search on pop-up. So that's one model that we're going to need. In this case, we are going to use a model in this top turtle right here. Using llamafile, we're going to is this mixed bread AI model. This is their extra. So there's a lot of different embeddings models out there. Use an open source one to make your life a little bit easier. Mixed Bread is a company that trains and open sources a lot of embeddings models. Specifically, their extra small model is very good. It is fairly small. It is, let's see, their GGUF model is 49 megabytes, which is fairly easy to run. That can even run on your phone if you want to. So that is the embeddings model that we're going to use in this case to run llamafile with it. What we're going to do is I've already downloaded llamafile before. It's on if you go to llamafile.ai in their releases section, they have a few different pre-compiled versions of llamafile that you can just download and execute as is. So I have the most recent version of llamafile. I pass in the -m flag and the path to the embeddings model that we want to use. And now we have a server listening on port 8080, a local server that will generate embeddings given the text that we want. So in this case, in Python, what we can do is we're going to use the HTTPX model, and we're going to define a quick little function that, given a string, it will return an embedding representation of that string. So in this case, I have, using this embed function that we just created, I pass in text and I get a list of floats in response. This is the embeddings that we're going to store and use to create a better search It's more of a fuzzy semantic search, so like a vibes-based search. But that's what we're going for using these embeddings. Again, llamafile it supports embeddings models, it supports completions models. So in this case, we have a small little Python script that hits the llamafile server that we have running locally, given text, it returns an embedding. There we go. That's it. We don't need anything else, right? We don't need any other fancy PyTorch or transformers or anything else that's available. All we needed was that one llamafile executable. We needed one GGUF file for the actual model itself, which we just download from Hugging Face. And that's all we need. So, and with a little bit of Python glue, we just make an HTTP request, get a response back, and we have a list of floats. That's the embedding that we're going to use to embed the data set that we have, right? Additionally, we're going to have a separate instance of llamafile running. So if you see on my terminal here, on the terminal at the top up here, this is where I have the embeddings model running. So this is listening on port 8080. What I want down here in a separate Windows terminal is I want to have another llamafile instance running, but this one of a completions model. So an embeddings model is very small. All it does is take in text and it returns a list of floats that represent that text. A completions model is a little bit more complicated. These models are much larger. These are the more like what you expect when you go to ChatGPT, right? It's a user who asks a question and you expect a response back in English. So these models are much larger, much more complicated. It wants to respond in like proper English and it wants to follow instructions. It wants to answer questions. So these are a little bit larger. In this case, we're going to be working with, there's a lot of different open source models to choose from. In this case, just to make my life easier, because this computer that I'm running on does not have a lot of RAM, you're going to use Llama 3.21b, which is a fairly small model, and it's heavily quantized to the point where it's only 900 megabytes, which is quite small. Some of the really good ones are dozens of gigabytes. So one that we get that like pretty good enough for 900 megabytes is pretty good, I think. So we're also going to start a llamafile server with that, but this time we're going to listen on a different port. So instead of the default 8080 ports, we're going to listen on 8081, so that way we don't have conflicts. So we have two instances of llamafile running, one that's hosting the embeddings model, and another that's hosting the completions model. So we're going to go ahead and get that started. And an example of how we can use that from Python is very similar to the embeddings endpoint, the embed function that we had above. But now we're going to use a different endpoint. We're using the 8081. So we're using the non-default one. And the HTTP request is slightly more complicated because it's a slightly larger JSON object, but not too complicated. But what we do is we provide a system prompt, a user prompt, and we specify that we want to have a response and want to have a text response, right? And again, it's very similar. We make a post request. We have a larger timeout because it can take a little bit longer for these completion models to return data. For example, the embeddings model, the one that we had before, a request of that can usually happen in less than 100 milliseconds. It's very quick to generate an embedding. But to generate a completion response using these larger language models takes a few more seconds. Again, the computer I'm running on is not that powerful, so it takes a few seconds. But it still should take no longer than 30 seconds. That's why we have timeout here. But again, yeah, it's just this one Python function that makes one HTTP request to llamafile using the JSON API, and then we could do some completions just based off of that. So for example, here I'm using the complete function where the system prompt is just saying that it's a helpful assistant. We ask for a very short haiku and it will respond after a few seconds of a haiku right here, right? So again, this is all we need in Python. We just make an HTTP request to the llamafile's server that's already running locally, and it returns back with text, right? Now, as a demonstration of how this large language model does not know anything about SpongeBob, even though it's a large language model, it's fairly small, it's running on my laptop, it does not know anything about specific SpongeBob episode plot lines. For example, if I tell it that, answer questions about SpongeBob, and I ask about this specific episode that happened, what happens to Squidward after he gets injured and wrapped in bandages? So if you don't know SpongeBob lore, in season 1, there's an episode where Squidward gets like extremely injured, so he's bandaged up in a wheelchair, and then they take him out to go jellyfishing. What happens after that is that when he goes jellyfishing, he gets zapped and he just gets injured even more. Classic SpongeBob. So that's what it should say, right? That he goes jellyfishing and then he gets zapped again and gets more injured, right? Oh, funny. But this language model, since it's so small, it runs on my laptop, it doesn't have context of that. So the response that we get when we ask it, what happens afterwards, it completely makes something up. So it references a different episode that happens. And yeah, it references several episodes that have nothing to do with the plot that we described. and just makes stuff up. So this is hallucinating about what actually happens. So again, a very large language model, ChatGPT or Llama 3.37B or whatever, those might know about specific SpongeBob episodes, but the very small one that we have does not. So what we're going to do is, now that we have a database full of SpongeBob plot episodes, we're going to try to build a RAG system where, when we get a query like this, what happens to Sponge Squidward after he gets injured or wrapped in bandages? We're going to take that query. We're going to find all the episodes that have, or all the episode chunks that are similar to that query, and provide those chunks to the LLM and be like, oh, using this context, what happens to Squidward, or answer this user's query, right? So hopefully when we do that retrieval using SQLite and SQLite-vec, you will get good context of what actually happened, provide that context to llamafile, where it will generate a response that will hopefully answer the question that we have. All right. So we have all the pieces. We have SQLite-vec, we have SQLite running, we have llamafile running with completion endpoints, and as well as embeddings endpoints if we want to do a vector search on top. So with that, now we're going to try and piece it all together and create a RAG system that will answer our questions about this very specific SpongeBob episode. Okay. So one more concept we need to know about is chunking. Now, every SpongeBob plot episode, these synopses are fairly long, right? The SpongeBob Wikipedia people, they're very dedicated to SpongeBob, so they write these very long-winded plot summaries about what happens in every single SpongeBob episode. Now, these can sometimes be a little bit too long, right? Where we can only provide the LLM so much context. We only have so many windows to provide, but also it can be a little bit, if we embed those very large summaries, the actual embeddings representation doesn't really represent what's actually going on inside. So this is a little bit hard to understand, but imagine this. Imagine you had a 1 hour long movie, right? And you only had 2 photos to represent what happens during that 1 hour long movie. Now, you can't fit everything about what happens in that 1 hour into 2 photos, right? Just like when you watch a YouTube video, the thumbnail that it gives you is not what really happens in the actual video. It's not enough context to give from just 2 photos in a 1 hour long movie. That's not enough context to give to figure out what actually happens during that movie. Just having one embedding for the entire plot episode isn't enough to really figure out what happened to that episode. So what we want to do is we want to chunk every single plot synopsis for every single episode. So if one episode has 5 paragraphs that talk about what happened in that specific episode, what we could do is we could create 5 chunks, so 1 paragraph per chunk, and we embed those. And so that way, when we start on top of those, we get more context of what happens inside of that episode. A little bit hard to describe, but imagine again, if we have a 1 hour long movie, instead of having 2 photos or 2 frames to represent what happens in that movie, instead imagine having 100 frames to represent what happens, right? With 100 frames, you know what's going on. You can get different scenes, different vibe of what's going on, as opposed to just 2. So again, we're just trying to get more context based by chunking and getting smaller representations of these plot episodes to hopefully provide better vector search. Now, there's many different chunking strategies. The main one that I have here, this is adapted from a project called Chonky. Chonky is a Python library that implements many different chunking strategies for RAG. Go ahead and check them out. But their most simplest method that they have is a chunk by words option. And what this does is that if you have 100 words and you want to chunk, in this case, I use an LLM to generate this function, but now we have a function called chunk by words, where if we get a long piece of text, we can specify that we want chunks that have 12 words each, and we want to overlap those chunks by 8 words. So in this case, we have, for this very long sentence, the United States has become increasingly, et cetera, et cetera. With this very long sentence, we want to chunk it up. So every chunk has at least 12 words in it, at most 12 words, and we want to overlap them by some amount. So in this case, we have an overlap of 8. If we had an overlap of 0, we can see that each chunk is completely separate from each other. But if we have a little bit of overlap, like overlap by 3, then we can see that the last 3 words in the first chunk are the first 3 words in the other one. This is just one strategy, one easy strategy to try to chunk up a document, but try to keep context in between it. So this is what we're going to try here today. We're going to use this chunking strategy with the data that we have. So we have the data saved in a SQLite database from the previous notebook, which we load in right here. So we're connected to this database. We load in SQLite-vec. So we have vector search available there. We perform chunks, and now you can see this gets a little more complicated. We chunk every episode plot point. We store them in a SQLite-vec virtual table where we could store the embeddings. And we also create a full text search table where we could store those chunks and sort them with full text search, which has some benefits over embedding search. We do the slightly complicated thing where we go through every single episode, we create chunks for every single plot point. We iterate through those chunks, we insert them into the specific tables. Again, getting more and more complicated. But at the end of this, we'll have a search engine where we can search through specific chunks that relate to every episode that we could use to answer a question. And again, after we have all that, we can create a lookup function that will perform vector search and full text search, a hybrid search solution over all the plot points. So given a user's query, we can get all the chunks that are similar. Again, getting more and more complicated, but it's all still one Python function. So we're still in this, right? So now when it comes to the actual like user that we have, so we have a query, right? So the query we care about is like what happens to Squidward after he gets injured. So what we do is we look up that query, we get all the chunks that are similar to it to provide context. We have all these chunks. This is what it looks like. For every chunk, we have the context. We have a chunked version of whatever happens to that episode. We have the episode name. So then we get this context. We feed it to a large language model. We gather the context. We ask the large language model. We give it a problem saying, oh, with this user's question, here's some context, answer the question using the context. And now we finally get results. After getting injured, Squidward becomes extremely deformed and severely subject. This is completely wrong. All right. So we did all that complicated stuff. We did sqlite-vec, we did chunking, we did embeddings. We did the search based off of a user's query. We provided to the LLM and it was still wrong. Which sucks, right? SQLite or RAG itself is very complicated. These LLMs are very complicated. We could try and do these complicated things with RAG and chunking and all that. And our first naive solution of what we tried just right now with all this complicated chunking and everything, we finally get a response back and it's still just as wrong as what we had before. Now we could go back and go through this example that we just had and debug what was going on. So for example, we can look at this context right here. Actually, we can open this in a larger file. We can look at, this is the context that we provided to the LLM. So we know we provided a chunk of an episode. Let's see. We provided a chunk to the episode along with the plot points to it. It was multiple different episodes that we gave. We can try to go back to try and reason and figure out what went wrong. Maybe there's a different chunking strategy that we could use, maybe a different embeddings model, maybe a larger completions model that's like smarter and can like reason about all this data better. But I think at the end of it, no matter what we did, no matter what we've tried, RAG is like really hard to get right. Chunking and the choice of chunking is very hard. Even in the case that we had where we chunked by words, there's a lot of different parameters that we can have. So for each chunk, how large, how long, or how many tokens in each chunk should there be? Should there be any overlap? Should we chunk by paragraphs instead or some other semantic meaning stuff? Choice is hard. The one that I'm running right now, because I'm running OBS, I'm streaming to Discord, I can't use a model that's too large or else it'll take too long. But if I use a larger one, would it make things better? Should I fine tune a model so that way it knows a little bit more about SpongeBob instead, or knows more about like English instead? So maybe with the multilingual model, but I'm only asking in one language. Maybe that degrades performance as well. Maybe the data that we're using is also pretty weird. If you read through these SpongeBob Wikipedia plot synopses, they're written in a very odd way. These hardcore fans about SpongeBob where they list every single joke that happens and all that. Maybe that's not the right data set that we need. Maybe we could use an LLM to rewrite those synopses to make it a little bit more friendly for search. Or maybe we can ask an LLM to take a plot synopses and just output a list of facts and search on those facts instead. Also, embeddings are pretty hard to work with. For example, the embeddings models that we used, like maybe it's treating words relating to SpongeBob in a very similar way, right? So maybe it's associating SpongeBob as Squidward as the same thing, but that's not necessarily the case. We need to know, because we're working with like plot episode synopses, we need to know whether Squidward and SpongeBob, we need to have a big distinction between them. But these general embeddings models, maybe they just aren't trained with that distinction in mind. So that's another thing to care about. Another thing is like users use your RAG applications in different ways, right? The query that we had, the one that I put in, was something like, the original query was like, oh, what happens to Squidward after he gets injured and wrapped in bandages? Maybe another person will ask a question in a different way, right? Maybe they provide context. Oh, I remember that there was an episode that did this and this. What was it? Or maybe they're like, oh, in season 2, I remember a specific episode. Does that kind of help in whatever? Users use your application in a very different way. In general, there's a lot of different things in play when building RAG applications that make building a good RAG application very difficult. But what But while RAG is very difficult, I think the tools that we use to build RAG should not be. And remember, we're using llamafile, like in this example that we had. Setting up llamafile and setting up sqlite-vec was like the easiest part in all of this, right? For setting up llamafile, we just had to download the executable, execute it, make sure it was running on an HTTP server, and then we could we could make requests to it, right? Same with sqlite-vec. It was a pip install away, and then we had a vector database that we can use. That was the easiest part. And that lets us focus on all the hard stuff. So now we can like experiment with chunking, experiment with, oh, maybe I could use an LLM to rewrite these plot synopses, or, oh, maybe I can use a different embeddings model that can know more about SpongeBob versus Squidward, all those things. And I think like before, even just a few years ago, this used to be the hard stuff, right? Running a large language model yourself used to be extremely difficult. That was the hard thing that you had to figure out. Or figure out vector search. That was the hard part. You would have to, maybe you would pay some service to do it for you, or that would be really expensive. And maybe they had a complex API or whatever. But all this stuff used to be the hard stuff, but now it's a lot easier. Llamafile is very easy to run. Same with sqlite-vec. So I think that's the main takeaway that I want you all to have, that like building a RAG application, there are many factors that go into it. You need to really know about your data. You need to know about your users and like what kind of questions they want to ask and get answered to. You have to like experiment with different chunking strategies or LLMs or completely different models to see what works best for you. But at least the fundamental tools that you use to build it, if you choose llamafile and if you choose sqlite-vec, hopefully those are the easiest part of building your RAG application. And you don't have to worry about, oh, how do I install PyTorch, or how do I like connect to my Pinecone vector database or whatever, right? At least those parts will be easy. So that way you could focus on more of the hard things, right? And again, like one thing I like about this demo and working on it, even though it just did not work at the very end and the results were just as confusing as they were in the very beginning, at least this demo was very easy to run, right? This demo, it was one llamafile download. So like to download the executable, it was a single Python script in a Jupyter notebook. There was one Dino script in a separate notebook just to scrape data. Although you can just imagine if it was a CSV or whatever, then you wouldn't need that scraping. You wouldn't need that scraper. And then it was two GGUF model files for that. So it was only really 5 files that we needed just to get started, just to get all the hard stuff out of the way, or at least all the things that used to be hard. So just to get the LLM stuff and the embedding models up and running. And now you can focus on the harder stuff, which is the chunking strategies. And maybe if I try to use a new LLM or whatever else. But at least that part is like the easy part, right? Now, even though I find this to be easier, like using llamafile and sqlite-vec, I still think it could be even easier, right? Having to like pip install sqlite-vec is easy, but at least it would be nice to have something that like just works out of the box, just like llamafile, as well as like building other custom logic with embeddings. We still had to like write the SQL to do embeddings, right? We had to write the create virtual table vec chunks using vec0, or the create virtual table FTS5 chunks, all that stuff we still had to write manually, which is still quite difficult. One thing that I tried out earlier this month was a enhancement to the llamafile project to include SQLite-vec inside of llamafile. So just like how we just downloaded the llamafile to run the completions and embedding support, if we could just include SQLite-vec inside of there and do a lot of embedding stuff for you, then maybe we can make this even easier, right? We could do all the embeddings generation, maybe some chunking. We could do all that stuff for you inside of llamafile. So that way you can focus on the harder stuff, which is the LLMs and all the other configuration options that you have. So my approach a few weeks ago was this new tool called Embedfile. So Embedfile, this is a pull request to the llamafile project. It has not been approved yet. There's still some things that I need to fix with it. But ideally, once it is done, this will be a project that will just be directly inside llamafile that you could use. And what it is, a command line interface that combines SQLite-vec and llamafile to generate embeddings for you. So a good example of what this looked like is right here. Just a little bit bigger so you can see. So this right here is a embed file. So just like llamafile, it is a single file that contains the model weights for this embeddings model. So again, the same mixed bread, extra small model that we're using before. It is now an executable file where it has a command line interface that we can use to embed text and embed other data. So in this case, we're using the embed command on the command line interface to embed the string hello, and it returns a JSON object that we have on command line. Just an example of what it works like. Just this one executable is all we need. No Python, no other dependencies. It has SQLite-vec inside, and we give it a prompt and it will return an embedding for it. Or we could do something a little bit more complex where we can import a CSV file, embed it, and store those embeddings in a SQLite database using sqlite-vec, which is what we do in this example. So here we use the same embed file that we had above. We use the import command instead, and we want to import the text column inside of this CSV file and save it into a SQLite database called dbpedia.db. And what it will do is it will loop through the all rows inside the provided CSV file. It will embed the text column and save those embeddings inside of a SQLite database, which is very quick because llamafile has a bunch of performance improvements to make this a very fast operation. This happens in 83 embeddings per second, which is quite fast on my older computer. And then once we have that, it has a search command, which is shown here, where we use the search command on the SQLite database that we just created. And we provided a query, in this case, global warming, and it will perform vector search on those and return the closest documents that match the query global warming in a with semantic meaning in mind, right? Again, I think the cool thing about Embedfile, which is coming soon, is that it will embed sqlite-vec and set a llamafile to have all the benefits of llamafile. Single file, works on all operating systems, embedding one model weight inside, with the benefit of sqlite-vec, which is embedding search and working with embeddings, make it a little bit easier to use from a command line interface. So I hope that this will make it even easier to work with RAG applications. You can imagine like maybe you have a CSV file, or you have multiple CSV files. You just want to like throw them all into a SQLite database and then do some RAG on top of that. Instead of writing it yourself using a Python script and like hand coding all this SQL stuff, maybe there could be a command line interface that that does a lot of that for you. So that way you can dive deeper into the implementation stuff yourself. There's also some other nice features on top of it. So for example, it has the SQLite command line interface built in. So if you want to eject out and just write your own SQL to do things instead of relying on the command line interface, there is an sh command that will do that for you. And then it'll drop you in a SQLite shell. You can write SQL or write SQL scripts as separate files and execute them as is. That is like some of the cool new features that will be a part of Embedfile that will hopefully be a part of llamafile sometime soon once I fix up this PR and it gets merged. So that's one upcoming feature to llamafile that I'm very excited about. Now, one last thing is, in addition to Embedfile, I have another project that I'm working on as part of the llamafile that I hope will be a part of the llamafile ecosystem sometime in the near future. Oh, one question before I talk about Jamfile. Oh, if you got some errors on the pre-built version, let me know what the errors are. We can try to figure that out. There's no server endpoint yet for Embedfile. I would say that llamafile, since it already has an embedding server as part of it, from the example that we had up here. There we go. I can just close this one anymore. So from this example right here, llamafiler already has an option to take an embeddings model and offer a very, very fast server for it. So I didn't want to add that to Embedfile because llamafile already does it and does it in a much better way. I expected Embedfile to be more of a command line interface thing where like you just have to run the command line interface. You don't have to have a server for it. If you do want a server, then llamaFile is already there and it's already much faster and that will do just as good. No plans for server flag yet. If people need it or if it makes sense, then maybe we can add it like sometime in the future. But it's not there as of for this pre-built version. If you do have errors running it, please, if you want to like either in the GitHub issue, if you want to drop the error messages that you're seeing, that could be helpful for me for debugging that and making sure it works. However, after working with Embedfile for a little bit, and again, it's still in a separate branch, it's not part of the llamafile project yet. One thing that I found frustrating working with it is that building a command line interface that works with all types of RAG applications is very difficult, right? Like I had the example import command and the example search command, but those are very limiting, right? All it would do is that it would like create a virtual table and it would store embeddings in there, but there's no configurations options, right? Like for example, there's no way to do quantization on the embeddings to use bit vectors instead of floating point vectors. And maybe you want that for a faster search, right? Or there wasn't a way to combine completion models with the embedding models to do whatever. So basically, I find to be a command line interface, while it's very fast for the default, oh, let me just build a embeddings table, it's not as flexible as I wanted it to be. One new thing that I'm working on, this is still, I don't have a PR for it yet. This is all stuff that I have locally on my computer. I will be putting up a PR soon, but I have another idea for something for an addition to the llamafile project called Jamfile. And what Jamfile is, it is a JavaScript runtime embedded inside of llamafile. And with the JavaScript runtime, we have an entire programming language at our fingertips, right? So if we want to do complex things like loop through all rows of a SQLite table and ask an LLM to generate responses for us, or use read files from the file system and embed them and then ask questions about it, or just have more flexibility of what we want to do outside of a HTTP server or outside of a command line interface, then a JavaScript runtime is a perfect option for that, right? So what Jamfile is, this is all stuff that I have locally, so I don't have anything online to share just yet. But what Jamfile does is just like llamafile, it runs as a single file executable, runs on all operating systems, can embed weights inside of it, but it can take in a JavaScript file just like this one. This is a demonstration where we read in a README file. We use a text embeddings model to chunk that file into chunks, just like we did before. In this case, we're just doing like very simple chunks. So just in this case, like 64 tokens we chunk the README into chunks of 64 token size per chunk, and then we perform vector search on that. What we do is Jamfiles have sqlite-vec built in, so we could create a database, create a sqlite-vec virtual table. We can iterate through all the chunks that we have, insert them into the SQLite table that we care about. We can console.log and do searches on top of it and print responses to the terminal. Basically, like a very flexible JavaScript API to llamafile APIs. So in this case, if I wanted to run it, let me just clear this. I could do jamfile run demo.js. Directory jamfile run demo.js. And just like before, it will read the contents of the README. It will, in this case, it did 204 embeddings in 3 seconds. So that's 56 embeddings per second, fairly quick. We provided a query. Once we embedded those and stored them in a SQLite-vec database, we gave it a query, Linux CLI tools, and then it returned responses of what that looked like. In this case, this is the README for the llamafile project. So like the results are a little bit weird because the README has like code inside of it. So it's a little bit awkward. But you can see the appeal here, right? Llamafile with a JavaScript API to run completion models or embeddings models or custom logic and save things into a SQLite database. That's like a much more flexible API, and it doesn't require an external Python process. It doesn't require an HTTP client to hit llamafile. It just all happens inside of just like another programming language, right? Just like Dino or Node.js or Bun or Python or anything like that. But it has all of these cool AI local LLM stuff built into it. For example, one fun thing that I was playing with, Justine in the Discord shared a script where she had a completion model that like would do spell check. So provide a document, it will take in that document, find words that are potentially misspelled and return them back to the user and be like, oh, replace this word with that word, powered using LLMs. So one way we could do that using Jamfile is right here. So we have a custom grammar here where spell check. So it's the GBNF. This is the grammar file that llamafile uses from llama.cpp, where we provide the LLM constraints of what it outputs. So it could only follow the constraints or the schema that we have. So what we have is, again, using JavaScript, we have this built-in completion model API here where we provided a model file that we have on the file system. We have a prompt where we tell it like, oh, you are an AI assistant. We provide a document. Please respond with all the typos that exist in it. And here's the document. Please find all the typos. And here's the schema that you could read in. So what we could do using this example, this is called spellcheck.js. So what I can do is I can feed in this text document that I have directly into Jamfile and run with the spell check. Run it on the spell check file, and it will read in that document from std.stdin. It will load in the large language model, read in the data, and it will output all the spelling mistakes that we had. I think one thing to note is that this is not going to be very great because this is a very small, heavily quantized version of the completions model. So I think Justine found that like the 27B versions, which are dozens of gigabytes large, work very well in this case. But here I'm running a 1B version that's like extremely small, like 1 gigabyte or something. So like the quality is going to be like pretty terrible. But if I had the proper RAM or a much larger computer, then this would be a little bit better. But you can see that it did output in the schema that we wanted. Correct helpful to helpful, skeletal is skeletal, and then it just goes off the rails after that. But the point still stands. This is all JavaScript running with llamafile, running locally on your computer. You can script it. You can write SQLite databases. In this case, I wanted to use structured outputs to find specific people that are mentioned in passages. So for example, here I had there's this YouTube show that I sometimes watch where it's like a 2 hour long video, but the first 30 seconds, they say, oh, it's like a podcast. So the guest says, oh, hello, my name is Alex. I'm from Los Angeles. I'm 99 years old. And this is financial audit. Like that's the intro that they say. So I ran Whisper to get transcriptions of the first 30 seconds. And now I have a LLM running using Jamfile to read in those the first 30 seconds of transcripts and output the information about each guest. So name, Alex Garcia. I am 99 years old. I'm in Los Angeles, California. And you could use structured outputs using Jamfile, using locally on a computer to structure output of what we have. And I can run this example actually. File financial audit. Oops. Where in this case, the transcripts are already in a SQLite database. So I just read in from that SQLite database using Jamfile, and then it outputs JSON in the schema that I specified, right? So now this is Lauren, 31 years old from Fort Worth, Texas, or Amber, 0 years old. So there's that hallucination. Things like this can make it a little bit easier to work with LLM. So that's a goal I have. Again, this is all a experiment that I'm running locally. I have not shared this with anyone. I haven't shared this with the llamafile team. I don't know if they even want something like this. I hope they do, but I will put up a PR soon. Feel free to try it out when I do it. I'll announce it in the sqlite-vec channel when it is available if you want to play around with this. But again, like I think the main thesis is right now working with llamafile and working with sqlite-vec is very easy. It is the easiest part when building a RAG system, because the hard part of RAG has to do with like your data and your chunking strategies and context and all that stuff. But if we can make that a little bit easier, so if we can fit that all into a nice little JavaScript runtime that runs locally on your computer, you can imagine a file called like rag.js that implements all the logic that you care about, right? It has llamafile built in. It has all the completion models there. You can you can imagine like some JavaScript helper functions for like different chunking strategies, like the one that we had before, or different eval methods. So you can track which experiments are working better and all that, all in like a JavaScript runtime that runs with llamafile, runs on all operating system, does all that stuff. That's the goal. So that's the goal with Jamfile. I will publish it sometime soon. The name I just made up, by the way, it could be a totally different name in the near future. I think I was going for llamafile, but with a J, because J for JavaScript. So Jamafile, but that just sounds weird. So Jamfile sounds cool. Like you can share jams with each other or something. That's a goal for Jamfile. And again, I will be sharing that hopefully sometime soon. It's a lot of fun to play with. I guess context if you care about nerdy stuff, but so llamafile is written completely in C and C++. So Jamfile, what it does, it takes Quick.js, which is a JavaScript engine written in C. It takes that engine and builds a runtime on top of it. So it adds other functions or other import libraries that are written in C for like reading files from the file system, right? Or connecting to a text embeddings model or to a completions model, and builds a JavaScript API. So that way, when you call it using in a JavaScript file, like I'm running on your computer, then it will like access those C functions to do whatever. So it's like building a new JavaScript runtime for like local AI applications, which I think is really cool. It is a very daunting task because JavaScript runtimes are very difficult to run and maintain. And Quick.js has its own little quirks, but I think it would be a fun little thing. And I think it will make running small experiments with RAG much easier. I think one thing to note, there are also other projects. What is it? What are those Python libraries that do everything? Oh, LangChain. Yeah, LangChain. And I think Llama Index is the other one. These are other frameworks that quote unquote do everything for you. You can say that, oh, I'm using llamafile and I'm using sqlite-vec, and it has APIs to try out all these different methods for chunking and context and all that stuff. That is all available to you if you use these like big frameworks to do all that stuff. Although I think they could be a little bit complicated to use and it might be a little bit overkill sometimes. So hopefully llamafile or Jamfile would be like a lightweight version of those things, just to make things a little bit easier, make it a little bit easier to experiment. Yeah. So yeah, that's all I have for today. I'll be around if you have any questions. So if you have any questions, feel free to throw them in the chat. Happy to go into more about like Embedfile or Jamfile as well. Or if you want to see more about like specific examples from the Jupyter notebooks that I shared before, happy to dive into that as well. Again, the Google Doc, which I will share again in the Discord. The Google Doc hack has links to everything that I talked about, including the slides. I will be posting a recording of this on YouTube very shortly. Thank you again, Matt, for recording it. Really appreciate it. And yeah, the slide for this will also be in the Google Doc, so feel free to share that with anyone and we should be good.